Okay, let's continue on our mathematical journey in trig, and let's talk about section 10.2. So in 10.2, we've got some new properties. Don't forget, we still will continue with 10.1. We can use those properties. But in 10.2, we're going to talk about sum and difference identities. So right here, you can see these sum and difference identities for cosine. So when you're taking two angles and subtracting them within cosine, it's the same thing as taking the cosine of angle A times the cosine of angle B plus the sine of angle A times the sine of angle B. And then the only difference when we change to addition between two angles is it becomes subtraction over here. So a lot of these formulas, there is a minor change from one formula to the next. So you can see right in here, in sine angle addition, notice that it's sine A cosine B plus cosine A sine B. Okay? And in subtraction, all that happens is you change the addition to subtraction. So these formulas, there's some, fine lines. With cosine, it's cosines first, then the sines. With sine, it's cosine, or sine cosine, cosine sine. So some things to watch out for. Again, when it comes to a quiz, when it comes to a test, when it comes to your homework, I'm going to give you this stuff because it's just unfair of me to say memorize this when sometimes there's just a fine line between this. I'm not that mean. In real life, you have access to this information. Okay, so I'm not going to really strip it of you, but you do have to know how to work these. And then down here, you can see the sum and difference for tangents. Okay. And again, it's really just a matter of changing the signs. So addition, the addition is on top, the subtraction is on the bottom. When it's subtraction, the subtraction is on top, and the addition is on the bottom. Okay? So we need to know how to work these formulas forwards and backwards. How we can take two angles and add or subtract them and then get some information from that, or how we can take this information where it's all been worked out for us and take it backwards to what we want. Okay? So let's take a look. So here's the first piece. It says, and these are like what the directions say, it says use the sum and difference formulas to find the exact value. So they want the exact answer to this. Now, if you go to your chart, which from here on out, you can use that chart all the way through. So I'm not going to limit you on this. If you look through here, you don't see a 7 pi over 12. Okay? But I can tell you that this 7 pi over 12, there are two angles on here that we can add, or two angles on here that we can subtract to get to 7 pi over 12. Okay? So it's kind of your job to figure out, well, what two angles can I use to add together to get to 7 pi over 12? Or in other words, what two fractions can I add that will give me 7/12 using any of these fractions in here? That's kind of the idea that you got to think to yourself, because we don't know what this angle is, but it is possible to break this up into an angle 1 plus some sort of angle 2, or it could be minus. That will give us, and we know that we will know these angles right there. So some of you see this is in radians. So basically I'm asking you what fraction plus what fraction, or what fraction minus what fraction will give you the 7/12. As we've talked about before, if you don't like working with this in radians, change it to degrees. And I know a lot of my students in the past, they loved changing this into degrees because it was so much easier to work with. Because in the end, we're looking for the exact value of this. So it doesn't matter whether we're in degrees or radians. In the end, we're going to be just fine. So if you don't want to think about it in terms of fractions, then think about it in terms of degrees. And 7 pi over 12 is sine of 105 degrees. So what two angles can we add together or subtract together to get 105? Well, if I take 150 minus 45, there's 105. If I take 45 plus 60, there's 105. Okay, and here's the radian values. So if you want to call it pi over 4 plus pi over 3, there is 105. That would be 7 pi over 12. Or if you wanted to say 5 pi over 6 minus pi over 4, that is 7 pi over 12. There are lots of other combinations you can use. I could take 135 minus 30. Or in other words, 3 pi over 4 minus pi over 6. That will give you 7 pi over 12. There are lots of combinations. It doesn't really matter which one you use. I'm going to show you both the addition and the subtraction, and I'm going to use the ones that I talked about. So I'm going to use the addition first. So if I take 60 degrees plus 45 degrees, and it doesn't matter the order either. So I'm going to come in here. I'm going to change this out. Whoops. And see how I'm working with this in degrees. It is, to be honest, a little bit easier to work in degrees. So 60 degrees plus 45 degrees. That is 105. And we know all the answers to 60 degrees and 45 degrees. We don't know the answer to 105. That's not on our chart. Okay? So all we're going to do is run the addition formula for sine. So the addition formula says sine of my two angles is going to be sine A cosine B plus cosine A sine B. Okay. So we're going to run sine A cosine B plus cosine A, which is 60 degrees, sine B. Oh, not the actual letter B, but 45 degrees. Because this is like my A plus B. And we know all these answers. Like I said, we know what sine 60 is. Sine 60 is, if I scroll up to the top a little bit more, sine 60 is the square root of 3 over 2. So this is the square root of 3 over 2. Fix that up a little bit. Times cosine 45 degrees. I know this one. It's the square root of 2 over 2. Plus cosine 60 is 1/2. Pretty sure on that. Let's double check just to make sure I'm right. Cosine 60, 1/2. And then cosine 45 is square root of 2 over 2. Not that. Because they do want exact values on this. This is why you can't just go into your calculator. Because you got square roots here. Okay? All right. So all that we're going to do now is we're going to put our fractions together. Okay? Into one giant fraction as a whole. So when I multiply, just multiply across the top. Square root of 3 times the square root of 2. We can do that. That gives us the square root of 6. 2 times 2 is 4. Plus, over here, when we put these two fractions together, 1 times the square root of 2 is just the square root of 2. 2 times 2 is 4. Since both of my fractions have common denominators, all I got to do is add. So you will end up with the square root of 6 plus the square root of 2, because they cannot get together. They are not like radicals, all over 4. And that's the answer that they will be looking for you to put in. You could also have, and again, this is not wrong. You could also have the square root of 2 plus the square root of 6 all over 4. That is just as fine as well. Okay? So let's do a different version. Let's do the subtraction, because some people might see subtraction. So I said earlier that 150 minus 45 is 105. Okay? So let's come back to this. Expand my page a little bit. So if we do sine of 150 degrees minus 45 degrees, and both of these we already know the answers to, we can figure this out because that is 105 degrees. So we're going to have the sine of A, which is 150 degrees, because A is always the first angle, B is the second. Okay? Cosine 45 degrees minus cosine 150 degrees sine 45 degrees. So let's plug in. Let's find what we know. So sine 150 is 1/2. Okay. Cosine 45 is square root of 2 over 2 minus cosine 150. Come on. Cosine 150 is negative square roots of 3 over 2. So negative square root of 3 over 2. Sine 45 is the square root of 2 over 2. So hopefully you can see, basically, this is just the same thing. Because what happens with two negatives by each other? They become positive. So in the end, you're dealing with the same numbers and operations that you had before. Just this time, this guy is in the back. This is why I also said this answer is A-OK as well, because that's the way this answer is going to come out. It's going to come out with the square root of 2 in front plus the square root of 6 in the back. Okay? Same answer. It didn't matter whether you did addition or subtraction. All right. Your turn. Go. Okay. So if we look at this, we need 195. Lots of ways to do that. So we could take 150 plus 45. Or we could take 240 minus 45. There's one way. Okay. Again, lots of ways to do this. It's all in the eye of the beholder. Or we could take 225 minus 30. That would be 195. Okay. So it's all about what you see. I'm going to go ahead and go with the addition one that I talked about. And again, there is more than one way to get 195. Okay. Your choice. So I could have also done 135 plus 60. That's 195. You figure it out. Just find two angles that either add to 195 or subtract to 195. Dealer's choice. I always like to do addition. So we're going to have cosine, and I said 150 degrees plus 45 degrees. So we're going to look at the cosine formula this time. So it says cosine, and we're adding. So we'll take cosine A, cosine B, subtract it from sine A, sine B. All right, easy peasy. We can do that. So we're going to have cosine. Again, it's always in order. This is A, this is B. Cosine 150 degrees times cosine 45 degrees. I don't know why I'm putting parentheses. You don't really need them. Plus sine 150 degrees. Sine 45 degrees. Okay? And we know what all these answers are. We just go to our Bible, our chart. Cosine 150 is negative square root of 3 over 2. Negative square root of 3 over 2. Cosine 45, just like last time, square root of 2 over 2. Plus sine 150, I believe, is a positive a half. Sine 150, yep, positive a half. Oops, wrong page. Sine 45 is the square root of 2 over 2. And repeat the process. This will be a negative square root of 6 all over 4. Over here, this will be square root of 2 over 4. And when you put it together, this is what you get. This is one possible answer. Negative square root of 6 plus the square root of 2, because they don't get together. They're not like radicals, all over 4. That's A-okay. Or you can have the square root of 2 minus the square root of 6 all over 4. Both of those are A-okay answers. Okay? And we would have gotten the same answer had we used the subtracted version of the cosines being added and subtracted. Okay? All right. Try this one. Go. Okay, so we can use adding or subtracting. It doesn't really matter, but I'm going to use subtraction on this one because I can think of it already off the top of my head. This is just 45 degrees minus 30 degrees. That is 15 degrees. So if we go to our formula, tangent says we're doing subtraction. So we're going to take tan A minus tan B, and then we will have 1 plus tan A tan B. Okay. So again, this is A, this is B. So we're going to have tangent 45 degrees minus tangent 30 degrees. It is minus, right? See, this is the one thing you got to be careful of, those pluses and minus. Yeah, it is minus. And on the bottom, it's the plus. So down here, we will have 1 plus tangent 45 degrees, tangent 30 degrees. Okay, so let's plug in what we know. Tangent 45 is the square root of 2 over 2 minus tangent 30. So tangent 45 is not the square root of 2 over 2. Tangent 45 is 1. Tangent 30 is the square root of 3 over 3. I almost messed that up. So this is 1 minus square root of 3 over 3. Down here, you will have 1 plus. Well, again, we know what tangent 45 is. It's 1. And we know what tangent 30 is. It's the square root of 3 over 3. So now it's just time to do some work. So I'm going to clean up the bottom real quick. So on top, we have 1 minus the square root of 3 over 3. And on bottom, we have 1 plus the square root of 3 over 3. Because 1 times all this is just the square root of 3 over 3. Now, what I'm going to do next is I'm going to basically apply what I know from intermediate algebra, which is I don't like fractions, so I'm just going to clear the fractions. Okay, I'm going to clear them out. So when I clear the fraction, this is what's going to happen. I'm going to multiply everybody by whatever the common denominator is. My denominator is 3, so all I have to do is multiply everybody by 3. So you get a 3, and you get a 3, and you get a 3, and you get a 3. When you clear the fraction, everybody gets multiplied by the same. Basically, it's your common denominator, the LCD, the least common denominator. So 3 times 1, that is 3. Minus Over here, these 3's cancel out because that's what clearing the fraction does. So I have a square root of 3 there. There's my new numerator. Down here, I will get 3 because 3 times 1 is 3. And then I will have plus because these two guys will just cancel out the square root of 3. And that right there cannot reduce down anymore. And that is the answer. Okay? And there you go. Just do a little bit of clearing the fractions. If you wanted to, you could have put this together as one fraction on the top and put this together as one fraction on the bottom and then do keep, change, flip. It's going to be the same answer. Okay? Because when you put this together as one fraction on top, I'll just show you that work real quick. You'll end up with 1 minus, oops, this meant to be a different color. You'll end up with 1 minus the square root of 3. Actually, sorry. 3 minus the square root of 3 all over 3. That's what's going to happen to the numerator when you put it all together. And then in the denominator, you get 3 plus the square root of 3 all over 3. And when you do keep, change, flip, the denominators of 3 here will cancel out, leaving you with this on top, and this guy flips, which goes to the bottom. Same answer. Okay? So if you put them together all as one fraction on top, and then to keep, change, flip, it works out the same way. I just like clearing the fraction. It's a little bit faster. Okay, less work. All right. Uh-oh. What's going on? Do we know what sine pi over 12 is? No. It's not on our list. Okay, there's no pi over 12 over here. So what do you think they're having us do? Well, this stuff up here looks familiar. Sine, cosine, plus, cosine, sine. I've seen that. I've seen it right up here. Sine, cosine, plus, cosine, sine. Oh, it's right here. Oh, I get what they're doing. Do you see what's going on? Yeah. We don't know these guys. But what happens if we go backwards and put them back together? Oh, let's take a look at that. So when we look at this, it's sine, cosine, plus, cosine, sine. So let's go through. Let's figure out which one we were using with. Oh, here it is. Sine, cosine, plus, cosine, sine. So we're using the sum of two angles. So all they want us to do is put things back together. So you're looking here at the sine of these two angles. This is A, this is B, of putting those back together. That's what you're working with. So let's put the A and B back in where they go. So this is sine of pi over 12 plus pi over 12. And again, you could have changed these from the very beginning and worked with them as such. Okay, so if you change these into their angles, this would be 15 degrees, 15 degrees. Okay, so if you add these together, leaving them as the fractions they are, you would end up with sine of pi over 6. That's what they are wanting you to figure out. Or in other words, if you added 15 plus 15, that would be the 30 degrees here. So you just go to your chart and tell me what is sine of pi over 6, or in other words, sine of 30 degrees. So sine 30 degrees, 1/2. They want you to take the formula and work it backwards. Okay? So you try it. Go. Okay, so hopefully you recognize this as one of the tangent sine or sum or difference. So we just got to know which one it is. So we had plus on top, minus in the bottom. It's right here. Oh, so they want us to do tangent A plus B. Okay? Because we don't know what 80 degrees and 40 degree tangents are. But we do if we go backwards, taking tangent A plus B. If I work this backwards of tangent 80 degrees plus 40 degrees, that gives us tangent 120 degrees. We do know tangent 120 degrees. Go to your chart. Tangent 120. Here's tangent. Here's 120. It's negative square roots of 3. Boom. Done. So if they give you something that's completely worked out, looks like a big complicated mess, most likely they are wanting you to recognize which formula it is and take it backwards. Because, and again, we don't know what these are. So that's even a clue to me that, oh, I probably need to go backwards. Okay? Because I know what 80 plus 40 is. That's 120. And that is on our chart. See? Nothing really crazy. That's what the bulk of 10.2 is like. Okay? Oh, now they ask a weird one. Okay, so sometimes they get these weird ones, and this says, write the expression of a function of alpha alone. So they want to know, in the end, if I take alpha plus pi, what is that going to look like? Okay, and in the end, they only want your answer in terms of alpha. They're not trying to be mean here. This is not as hard as what you think it is. Again, if you don't like radians, turn it into degrees. Pi is 180 degrees. Okay? So all they want you to do is really just plug into the formula and simplify. So cosine alpha plus pi, when we look at that formula, we're doing plus, so we'll need to take cosine, cosine, minus sine, sine. Okay. So we'll have cosine alpha, cosine pi, minus sine alpha, sine pi. Okay? Well, we don't know what alpha is, but we sure as heck know what pi deals with. So cosine pi, go to our chart. Cosine of pi is down here at 180, so cosine of pi is negative 1. So we've got cosine alpha times the negative 1 minus, we don't know what sine alpha is, so that stays. Sine of pi, so sine pi is 0. So we're taking sine alpha times 0. Well, anything times 0 is 0, so this just goes away. And negative 1 times cosine is just negative cosine alpha. That's what they're looking for as your answer. Just a little bit of simplifying. Nothing crazy, I promise you. A lot of this is plug and chug, as I call it. Okay. And then last but not least, I think this is the last one I have. Yeah. Again, they go back to like what we did in 10.1. Can you verify that this side equals that side? Okay. And don't forget, we now have some new identities that we can use. Okay. All right. So we don't actually need that anymore. I'm going to get rid of my calculator. We don't really need it. So when we come back over here and we're looking at this, oh, notice I see two angles that are being added up here. So I probably want to take this side and mess around with it and change it up. Okay, so let's do that. So we need to change this into what we know cosine sum angles are. So that looks like this. You're going to have cosine alpha. This symbol right there is beta. Okay, and then you'll have cosine beta, and then it should be minus sine alpha, sine beta. And all of this is over cosine alpha sine beta. Okay? So, again, I told you in the previous section, if you have subtraction or addition in the numerator, that just means that these were two fractions that were added and subtracted together. So let's separate these out. So we got cosine alpha, cosine beta, all over cosine alpha, sine beta, minus sine alpha, sine beta, all over cosine alpha, sine beta. Hopefully you notice some things are going to cancel out, like over here in this first fraction, those are gone, leaving you with cosine beta over sine beta. Oh, we know what that is. That's cotangent beta. Over here in the second fraction, the sine betas go away, leaving you with sine over cosine. Oh, we know what that is. That's tangent alpha. And then, of course, there's subtraction. Oh, look, we just verified it. Check. Done. Okay? So, that's the kind of verifying that you have. And I think there's one, maybe two problems like this where you verify. Most of everything else is plugging and chugging into the formulas. Okay? You got this. And that is section 10.2.